You gaze into the night sky, a canvas of darkness punctuated by twinkling stars. Yet, have you ever wondered why space, filled with billions of stars, is dark? Let's take a moment to contemplate this paradox. Imagine, if you will, the universe. An expanse so vast it's almost beyond our comprehension. This infinite universe is teeming with galaxies. And how many galaxies are there? Well, let's just say if you were to count every grain of sand on every beach on Earth, you'd get close to the estimated number. Now consider that each of these galaxies is home to billions of stars. That's a lot of stars, right? Now if we were to apply our earthly understanding of light and darkness, one would assume that with such a vast number of stars, the night sky should be ablaze with their collective light. No corner of the universe should be dark. The light from these billions of stars should be so overwhelming that night, as we know it, should not exist. But as we all know, when we look up into the night sky, we don't see an illuminated mural of starlight. Instead, we see a black backdrop, peppered with distant points of light. The stars are there, flickering in the distance, but they don't light up the sky as one might expect. This is a puzzling contradiction. So why is this the case? How can the universe be filled with so many stars and yet be so dark? It's a question that has perplexed scientists and stargazers alike for centuries. But here's the catch. If the universe is brimming with stars, why doesn't their collective light illuminate the night sky? In this video, we will delve into this fascinating cosmic conundrum and attempt to shed light on why the universe, in all its star-studded glory, remains shrouded in darkness. Stay tuned as we journey into the depths of the cosmos to unravel this stellar mystery. To comprehend this paradox, we first need to grasp the basic structure of the universe. It's like a grand cosmic tapestry, woven with an array of celestial bodies, all moving and shifting within an ever-expanding expanse. This vastness is measured in light years, a term that refers to the distance light travels in a year. And let's not forget, light is the fastest traveler we know, moving at a staggering speed of about 186,000 miles per second. Now consider this, the universe is not stationary, it's expanding, like a balloon being inflated. This means that stars and galaxies are constantly moving away from each other and from us. Now combine this with the concept of light years. The light we see from a star isn't its current state, but an image from the past. The further a star is from us, the older the light we're seeing. So imagine a star so distant that its light takes billions of years to reach us. If that star were to explode into a supernova today, we wouldn't know for billions of years. The light from this event, traveling at its breakneck speed, would still need time to cross the seemingly infinite cosmic distances. And here's where it gets even more intriguing. Some stars are so far away, their light hasn't reached us at all. They exist or perhaps existed, but we remain oblivious to their presence or their fate. The universe may be sprinkled with countless stars, but the light from many of these hasn't had the opportunity to traverse the vast cosmic expanses and strike our eyes. This concept is a crucial piece of the puzzle when it comes to understanding why space appears dark despite the existence of countless stars. It's not about the absence of stars or light, but the immense distances and the element of time that light needs to travel. So, the light from many stars, no matter how numerous or bright, hasn't had the chance to reach us yet. This paradox, known as Olber's paradox, has puzzled scientists for centuries. It's an intriguing conundrum that asks an essential question. If the universe is infinite, static, and ageless, why is the night sky not blazing with light from countless stars? Why is space dark when it is filled with so many stars? Let's break it down. The paradox is named after astronomer Heinrich Wilhelm Olbers, who didn't actually discover it, but popularized it in the 19th century. It goes something like this. Imagine an infinite static universe that's been around forever. In such a universe, every line of sight would eventually land on a star, right? So, why doesn't the infinite number of stars make the whole sky light up at night? The key to resolving Olber's paradox lies in understanding the nature of the universe itself. For centuries, the concept of an infinite, static, and ageless universe was the prevailing belief. However, as our understanding of the universe evolved, so did the answers to this paradox. The first piece of the puzzle was the realization that the universe is not ageless, but has a finite age. Scientists estimate the universe to be about 13.8 billion years old. This means that we can only see the light from stars that has had enough time to reach us, limiting the number of stars we can observe. The second piece of the puzzle was the understanding that the universe is not static, but is continuously expanding. This expansion causes the light from distant stars to stretch and shift towards the red end of the spectrum, a phenomenon known as redshift. This redshift dims the light from distant stars, making them too faint to light up our night sky. So the answer to Olber's paradox isn't that there aren't enough stars, but that the light from many of them hasn't reached us yet, or is too faint to see due to the universe's expansion. It was the realization of an expanding universe that provided a solution to Olber's paradox. This understanding has helped us unravel other mysteries of the cosmos, and continues to shape our exploration of the universe. Now let's delve deeper into the universe's dark secret. As we journey through the cosmos, one concept that we must grapple with is redshift, a phenomenon that's part of the universe's darker secrets. Picture this. You're watching a star race away from you at incredible speeds. As it moves, the light it emits changes. It's not that the star itself changes color, but the light waves it emits get longer as they race to keep up with the star. This stretching of light waves is what we call redshift. Now, why is it called redshift? Well, when light waves stretch, they move towards the red end of the light spectrum, which has the longest wavelengths. The faster a star moves away from us, the more its light shifts towards red. This is why distant galaxies hurtling away from us due to the universe's expansion appear redder. But here's the twist. Redshift doesn't just affect color, it also affects brightness. As light waves stretch, they spread out. This means the light from distant stars gets diluted, becoming less intense, less visible. So much of the starlight in the universe is stretching, spreading, and dimming until it's beyond the reach of our eyes. And there's more. The universe is awash in cosmic microwave background radiation, or CMB. This is the afterglow of the Big Bang, stretched out over the entire universe. It's everywhere. But because it's been redshifted to such long wavelengths, it's in the microwave part of the spectrum which our eyes can't see. So, we have this paradoxical situation. The universe is full of light from stars and the CMB, but because of redshift, much of this light is stretched to wavelengths beyond our sight. And because the light is spread out, it gets diluted, making the universe appear dark. So, the universe appears dark to us because the starlight gets stretched out, diluted, and shifted to wavelengths beyond visible light. The darkness of space, it seems, has its roots in the very nature of the universe itself. Just as we've journeyed through the vast cosmos, let's embark on a brief recap of our cosmic mystery. We've understood the universe's mind-boggling vastness, an expanse so large that we can hardly fathom it. This infinite universe is always expanding, growing larger and larger with every passing moment. Then, there's the speed of light, an unchanging constant that shapes our perception of the universe. Light from distant stars and galaxies takes time to reach us. In fact, when we gaze upon these celestial bodies, we're looking at ancient light, a snapshot of the universe as it was billions of years ago. And who could forget the redshift? It's a fascinating phenomenon where light from distant objects gets stretched out, shifting towards the red end of the spectrum. This happens because of the universe's rapid expansion, causing light waves to stretch along with the fabric of space itself. All of these factors, the universe's vastness, its expansion, the speed of light, and the redshift, play their part in the cosmic drama that makes space appear dark. But it's not just an empty darkness, it's a canvas filled with the story of the universe, a tale told in the language of light and time. The universe isn't simply a dark void speckled with stars, it's an ever-changing entity, a cosmic dance of light and darkness. The darkness we see isn't an absence of light, but rather a consequence of the universe's vast scale, its relentless expansion, and the very nature of light itself. So, next time when you gaze at the dark night sky, remember, it's not the absence of light, but the universe's expansion, the speed of light, and the stretching of light that makes space appear dark. Our universe, it turns out, is a lot more intriguing than what meets the eye.